have you here tonight. We haven't we haven't met in real life. I think this is the case with my guests, but we are in contact for quite a while now, and we even talked about a podcast a few times. So I'm very happy that you took the time tonight and being my guest. As you might or might not notice, this is a different environment here, different background. I finally moved, I am in the middle of moving. As you have seen, I've started a new job at Robotics here in Metzingen, and yeah, this is my new flat. Myself and my family will move here finally within the next few weeks, and I hope even in this kind of environment, the sound will be all right, the light will be all right, and yeah, you have a good time. Back to you, Eike. Maybe you can introduce yourself and tell us a little bit about yourself. That would be nice.
Yeah, nice to meet you in person. So yeah, we just talked, I think, a little while over LinkedIn. So LinkedIn is an awesome network. So to introduce myself, I'm one of the founders and CEOs of Robotop, and I've quite also a background in the field of robotics. So I think that's also a little bit the topic of today. And so I'm very excited for the exchange tonight or this evening. And yeah, let's get started.
Yeah, what I always do is ask, are you one of those persons that has been very interested in robotics very early on, or did you came to the topic later on? That is always my first question, because I'm interested in, is that a straight path, or is that a path with a few detours? Maybe you can go back in time a little bit and yeah, elaborate on your interests in robotics.
So yeah, it's quite a interesting question. I also thought a little bit about it, and like, I don't know if you're familiar with Lego, but I'm a huge fan of Lego. So during, I think, my childhood, I did a lot of like building stuff with Lego. And so this is a topic like building stuff, constructing stuff, ramping stuff up is really, yeah, fun for me. And like building these bricks together, I think it's, as you say, maybe the first step, but also, yeah, when I look back into my time at school, so I'm also the guy or person who is more interested in mathematics, physics, and stuff like that. So this came always naturally to me. And I also was, yeah, not so the biggest fan of our school systems, because yeah, it's for me it was not so fun as Lego, to say it. So for me, I started going in this direction. Also, like in Germany, it's called the Abitur, did my Abitur, and yeah, then thought about what to study. And yeah, I studied mechanical engineering, but at first I didn't get into robotics because at this time robotics was not so known. So my mother worked at the time at Siemens and did like something with speicherprogrammierbaren Steuerung, so SPS, but I didn't understand what it was. So that's, I think, the main problem of our education system. You really don't understand industry, and this was, yeah, maybe the main reason you don't think about robotics in the school system. So I did like 2008 my Abitur and start studying Maschinenbau, so mechanical engineering, and then I, yeah, stepped a little bit more into robotics because I started tutoring students with Lego Mindstorms EV3. Do you know what's Lego
Interesting.
Mindstorms
Yeah,
EV3
no,
is?
no. Do
Yeah,
you have
it's
sorry, do you have siblings?
yeah, a little brother. So a little brother in question marks because he's 1 meter 90, 110 kilo, and a professional handball player. So he
Okay.
plays first and second league handball. And yeah, he's also somehow the reason I got into mechanical engineering, because he was the guy who knows every car configurator and knows
Mm.
every configuration of cars. And so I thought about what to study, and I thought, okay, nothing to do with languages. And so I came in the direction more of mechanical engineering. And also my mother provided me with or gave me the contact to Siemens. So I did an internship at Siemens for 6 weeks in the mechanical basic stuff. Yeah, and I really enjoyed it, and I found it very interesting. And so, yeah, I started studying mechanical engineering.
A lot of people in robotics, sorry, and a lot of people in robotics have different kind of backgrounds because robotics is so wide, right? So there's a lot of things
Yeah,
that you can do and that you can start. Actually, I meet a lot. I mean, a lot of people that are in doing mechanical engineering or come from mechanical engineering. As myself, I have a background in mechanical engineering as well, and there's then computer science, all the different things, right? And nowadays there's more and more courses, more and more degrees in robotics. I remember that back then, especially for example, I started in Berlin. There was no directly robotic division. There was Verkehrswesen, and there was different options. But nowadays it seems that there's really the hype is big and it's popping up everywhere. So I think today, especially with all the different courses that are existing and videos and self-tutoring, I had a few guests here that did this kind of path. So yeah, I'm very interested in how you started tutoring people, but then you finally decided to do something on your own and going deep into that direction.
yeah. Yeah, so also the reason why I studied mechanical engineering is also a little bit random to a different point, because I was like at the university visiting different study options. And we went there, and I was the driver of the car. And my best friend got hit by a car, and I drove him to the hospital.
Mm.
And so I missed like the study information about economical engineering. So I would also study it some way, some typical engineering subject, but more into the economical part. So that's the
Mm.
reason I started with a Bachelor of Mechanical Engineering, because I drove my friend into the hospital and went there basically the whole day with him, because he got hit by a car, but it was not so bad. But yeah, it looked somehow very crazy, because he was hit and fly through the air and
Oof.
had a little bit blood in the head. And yeah, it was somehow the
And he wanted to
happenings of
study,
life.
and he wanted to study mechanical engineering.
Um, I thought about the different kinds of studying. So we had like mechatronics, mechanical engineering, and economical engineering.
Mm.
And I'm always the guy who was interested in somehow the economical part, but also in the engineering part.
Mm.
And though I thought about economical engineering, but started with mechanical engineering, but later on did two masters. So I did a master also in mechanical engineering, but also additionally a master in economical engineering. So I mixed it up a little bit later, but that's somehow the reason I started with mechanical engineering. So
Mm.
to some point, I think, especially in your early days, some decisions are a little bit random, because, as you said, there are different influences around you and things that happen and you can't predict. And yeah, but that's life. And during the study, and I think that was what I really enjoyed, is the Lego Mindstorms EV3 tutoring. So I went also uh, very early in informatics. So I started like as a tutor for informatics because I really liked it. And later on also worked as a Lego Mindstorm EV3 tutor. So there was a company called ETQ in Munich,
Mhm.
and they
Mhm.
founded like I don't know the English word, so Stiftung. So for Technik macht Spaß Stiftung. So it's basically an organization to bring more technical education into the school system. And they
Nice.
gave us a training, and they had like a basic training for a workshop for pupils to play with Lego and to learn like basic of robotics. So the basic workshop I'm doing is like in 4 hours building a robot, connecting sensors, and programming the robot so he can drive along a black line and interact with objects, and that in 4 hours. And I think this for the later part in the story, it's a very important part, because when you connect this to industrial robotics, then it gets really weird, because like at the time I started in industrial robotics, you need like a 2 weeks course just to know how to program a KUKA robot. So on the one hand side, I teach in 4 hours children at the age of 12 to build, program, and interact with a robot. On the other side, you have like industrial robots who are so badly to use, because like industry doesn't care at all about usability. And I think that's also what's fascinating me about robotics and also informatics and usability, is just Lego achieved children could do this. And you basically need a PhD to program a robot those days. So a little bit crazy. And so I started with tutoring students with the stuff, and I really enjoyed it, and did it basically my whole time. So I did it as a student and did like workshops for Ferienbetreuung, so holiday entertainment for kids at the university, but also for new recruits for studying. And later on also I continued my path with a PhD. So like, yeah, my love merged a little bit with 3D technologies. So to roll it a little bit back, I started like with laser technology, because at the time I was very fascinated about laser technology, and I did my bachelor's with ultra short pulsed lasers. And I created like nanometer sized structures, and it's very fascinating. So you can like move particles with light and stuff like that. So I was very fascinated about that. But during my bachelor thesis, I was like standing hours and hours in the laboratory and was like searching nanometer big particles under a raster tunnel microscope. So I was at the end, I don't like that scale so much. And you
Yeah, I
have
can
to do a
imagine.
lot of like with breaking stuff and fixing, and like, and so in my master's I was going a little bit more in the direction of software. And during my master's I did an internship at Bosch Rexroth, and like was working more into the direction of image detection. So were basically programming an app to detect errors in production parts.
Okay.
So it was also very interesting. So I got more into programming, but in parallel always was doing like Lego tutoring and also informatics tutoring. And from this point on, I found a very interesting master thesis. So I don't know if you know 3GS.
3GS. No, it doesn't ring a bell.
So it's basically a 3D web technology platform. So you can build in a web browser a 3D environment.
Okay.
And I really enjoyed it, because the time before you program something and you don't see anything. So you program code and just some lines come out, and it's, yeah, to some point interesting, but sometimes not so much for me. And that's what I liked about robotics and what I liked about 3D technology. When you program a robot, you see what the robot is doing. When you program 3D technology, you know and see the results. So
Interesting
though,
combination.
I really liked both. And yeah, that's the way I started my journey into 3D technology. And I like built some robotics um, for battery production in 2015. So we built like a Werkeinformationssystem. I think it's somehow translated in to teach people how to build stuff together.
Mhm.
And I was combining also a robot which was doing some specific parts. And
And was
so
this,
that's what.
sorry, was this still doing your PhD phase, or was this afterwards?
Oh no, it was my master thesis.
Okay, sorry.
I did it as my master thesis, and so I really enjoyed it, and I did it at the factory Institute for Factory and Factory Automation is also where I started my PhD. And so I was into robotics more, but more into the digital planning stuff.
When they
And
are building up building up robots is very expensive. Just today we've been to a customer site and they're building up a line for their customer, and it's a massive line. And
yeah,
if you could simulate building up the line, you wouldn't need necessarily the entire line to see if that's what you have thought of would work, right? And but
yeah,
there's a lot of things that you can simulate, but there's a lot of things that you cannot simulate, and or not yet
yes,
simulate. And yeah, so it's very interesting that you say, so this is the direction or where you're coming from, or where this master thesis is starting in this kind of area, because there
yeah,
is a lot of potential in it as we get more and more robots, and yeah, planning gets more and more complex. So yeah, please continue.
yeah. And also during my study, I was also working at another company as a student, like programming with
Mhm.
LabVIEW robots. And it's to some point very interesting because Lego Mindstorms, the programming surface or the old of the EV3 is a downgraded LabVIEW. So basically it's a graphical programming interface and it's basically based on LabVIEW.
Mm.
So yeah, a lot of interesting strings coming together. And I think what's also important for my way is like I was also during my time at school, but also at university, a big fan of strategy computer games and also different other kinds of computer games. And what's very interesting, you play the strategy games and like 1995, 3D games started to get more common. But when you look at our education system, and we have nearly 2025, so basically 30 years later, we have zero 3D technology at our schools.
Mm.
So the knowledge at our schools, we're starting a little bit with 3D printing, but if you look at the basic parts of most of the German education system, you have a little bit 3D printing stuff and little bit like ChatGPT. But you have nearly zero 3D technologies. In times you have computer games who are so realistic, you nearly can't differentiate from reality.
So, in your opinion, I mean, there's computer programming happening, right, in schools. I do remember that during when I was studying mechanical engineering, we had a obviously computer programming as well, but and then there was the option for to study Fortran. So yeah, I can definitely understand what you're saying. So how much we are behind and what is actually available and what kind of
Yeah,
videos you can see at YouTube any day and how many free resources are and the big companies are giving even the option to do your mini degrees or get some certificates. Google is doing it. All the big companies are doing it, and then
yeah,
going back to school and see how's the starting point, especially compared to other mostly Asian countries. Where are we standing? And you were mentioning a 3D simulation or programming in general. This is almost non-existent. So
yeah,
you're obviously right that there's a big gap to close.
yeah. And like the comparison is especially interesting if you come out of the school system and then you start using it doesn't matter any cut or in any industrial software. And the usability feels so bad. It feels so bad. So it's really a pain to use some of these tools.
Yeah, true.
And I spent hours and hours and hours. And we had like in study, we had a exercise, like it's called construction exercise. So we had to build some specific crane to yeah, as a work for studying. And I did some little mistake. I added profiles which have a lot of rectangles, and therefore I have to add some parts to put it together. And we slept on the floor in the computer room to finish the construction because we had to share workplaces, and it took so long to do one step in the software because the computing was so slow because they are so badly programmed. And also are, if you do some mistakes like over construction of a screw, you wait for hours and the software crashes. So it's not only bad to use, it's also very slow, and it's no fun, especially if you have a deadline.
And which school, which university are we talking about?
What do you say?
I was asking, so which school or university are we talking about? Can you name the name of the?
So yeah, we were at I was in Erlangen, so in Friedrich Alexander University, but basically it doesn't really matter. It's like every software use. So we switched. I don't drop any name to like bully some of the companies, but you can like take one of the big software companies of CAD, and at the time our university switched a little bit licenses due to different models, and then yeah, switch it, and we use different one, and it doesn't really matter. So every CAD software was very, yeah. Also there are like big companies everyone is using every day, and yeah, the
But I
usability
mean,
is so bad.
yeah, I mean, I'm all with you. Just yesterday had the conversation again about usability and being customer focused. But I do understand that there's some limitations when it comes to these kind of things, right? So I studied mechanical engineering and switched later on to aerospace engineering. So there's specific cut software that you need that you're using in this kind of industry. And the thing is, the products that you are creating, that you're constructing, right? They need to be in business for decades. So if you're designing a plane, the plane and all the parts of the plane, you need to supply spare parts for 30 years. So this is contracted, right? So, and if you think about it, so if you're coming up with a new, let's say with a new version, you still need to support all the other former existing ones. So starting greenfield is almost impossible because you have you're still in business with the existing 29 years before the new version you're releasing, right? And as I was working for Siemens in Berlin, now Siemens Energy, we're producing large gas turbines, and
Yeah.
they're it's the same thing. You're selling these kind of gas turbines to produce energy, to produce electricity, and they're in business for a very long period of time. The business is in refurbishment and service. And so every now and then you get a call. So I have this product here. This had been in production for 25 years, right? And you have the circles where you need to give new parts. And the software that you are using for constructing these kind of things, right? You still need to be able to supply that. So I feel you in terms of the usability is trash. This is the reason why a lot of things happened in the last 15 years with the startups, because they're trying to democratize this kind of processes, and they do not care about the existing business. They're trying to open up new businesses. They are coming up with, let's say, doing a digital twin for model where you don't have a for product where you don't have a cut model, right? But yeah, I'm totally with you. We do need to find a solution, making these kind of things more accessible, easier to use, more intuitive. I'm totally with you. But maybe this is a good bridge to what you're doing today. Maybe you can we can come to this part, and you can tell me a little bit about what you're doing today.
Yeah, so like to build the bridge, I try to continue with the story. When I started my PhD, I got first year project with Siemens also, and that was a time where Universal Robot was a rising star. So I think you're also familiar with Universal Robot, and also very interesting. Universal Robot said, okay, we are doing cobots and human robot collaboration. So from my point of view, this was a marketing gadget, but the real innovation from my point of view was the aspect of usability. Or as a colleague of mine said, okay, you can take the robot out of the box and use it. And like, as I mentioned with the KUKA, at that time, you had to have 2 weeks training on the software environment. It was not intuitive. So I think a Universal Robot introduced the touch panel. So as you mentioned, yeah, you have a little bit legacy stuff. You have to work around and play around. But if you look at the current market, Universal Robot forced every big robot company to introduce also a touch panel. So yeah, that's also, I think sometimes companies also need some external force that said have to do something, because also a lot of people in the current time before said, yeah, but everything is working and everyone is happy and it has to be like this. So also a lot of company are defending the current state of art. Different factors, like they have legacy software and would be very expensive to change, as you say, maintenance. So it also is a maintenance problem to switch to newer stuff, because as you said, industry, you have to supply very long maintenance. But yeah, and then I was also like at the university writing like research proposals for contracts. So for people who don't know, like in Germany, you have like a research landscape, and most universities have some basic funding. So 1, 2, 3 employees and the professor, and some money is given. But then you can apply for research projects, and therefore it's like a competition, and the best projects win. So every university and everyone can apply, and there was like a project, digital industry or digital technologies for industry, and this was a big robotic project. So it was about 2007. 2017, sorry, 7 would be a little bit back in time. And in this time, and we like had a proposal from the University Erlangen-Nuremberg with a Robotop. So what it was, yeah, depending what you count. So the research funding or the project volume, it was 2 to 4 million project volume, and we had like partners like Schunk. So big partners, and Bosch was a partner, and also smaller companies, so Icarus, Infosim, and also big German research institutes like the Friedrich Alexander University Erlangen-Nuremberg, KIT, LPS, so Dortmund and Bochum, and EPS. So it was a huge project over 3 years. And that was basically the basic idea of Robotop. So that platform enabling getting access to robot automation as easy as, yeah, a one-stop shop. So you go online, you configure it, you plan your stuff, and then you can order it. So this was basically the idea of the research project. And so I was in a project lead for 3D web configuration and digital planning on robotics. And so we thought a lot about how to modularize, how to standardize, how to make the stuff accessible. And also this was also the aspect of usability again. So not only how to make it more easy on the back end side, but also on the front end side. So we played also a lot of around with usability, and it was also the time 3D and extended reality started to grow up. So it was a time the HTC Vive Pro got to the market. And like for the people who don't know it, it's like one of the first, from my opinion, very good virtual reality headsets. And it has a very good tracking, and also the view was very good for that time. And also we did demonstrators with HoloLens 2 and all the different technologies, and also started with 3D smartphone scanning. So there was a smartphone like a Google Project Tango. So Android and Google was the first who was integrating a 3D scanner in a smartphone. And so we also was using like scanning with your smartphone, the environment to integrate it. But sadly, Google skipped that project and Apple integrated it, but with different technology. So later on, that's also what a lot of people don't know, their smartphone. So if you have a Apple iPad or Apple Smartphone Pro, you have a 3D scanner in your smartphone. So it's also very interesting. And so we played a lot.
Just to go back to the platform, because it's not entirely clear for me, and maybe for some listeners as well. So the idea of Robotop is being able to create an environment or like a simulation, but in a much easier way. So is that correct?
Yeah, that was the original idea of the research project. So it was like combining online shop and simulation and configuration. So it was like a big vision, but also what you have to know about research projects. So you're not allowed to develop a product during a research project.
Yeah.
You just develop a prototype. So it's according to some laws for competition. The governments are not allowed to bevorzugen, so to give some companies some advantage. So you have like research funding, but it's just allowed to a certain technology level. So what you basically do is you try a lot of, you discuss a lot of, and you play a lot of technologies, and then you build some prototypes to validate some specific ideas. And that was also the area where I wrote my PhD thesis in. So I built like with my PhD thesis about 3D web configuration. And that's also where I worked a lot of about like knowledge-based systems. I don't know if knowledge-based systems say something to you.
Yeah, but maybe you can elaborate a little bit on that.
So for people who don't know, there was I don't know if I'm totally correct, but about 1980s plus minus was a first AI hype.
No, I think it was a bit earlier, but yeah.
A little bit earlier. So there was an AI hype, and in this AI hype, knowledge-based systems was a big part of AI. So basically, the idea of early AI is to replicate human wisdom. So not only like large language models, but also to remodel human knowledge, to have like systems that then can create human-like results. And that's like the first configurators, like knowledge-based systems. And it's a lot of about how to structure specific knowledge so you can use it like for specifically a car configurator or stuff like that. And these technologies is a basic for a lot of systems, but it's also a little bit a lost knowledge. And it's very complicated, so I switched to a...
And it failed back then. So this is back then it failed. This knowledge system that they were trying to build. The hype was big, but it failed.
Yeah.
The expectation were not matched, and so this was one of the reasons for this AI winter we had. So funding and everything, and then development,
Yeah, it's
R&D, and all these
dropped.
things, they just dropped, right? And it took a few more years because it was a burn topic. Nobody wanted to touch it anymore. So
Yeah.
yeah, but please continue.
Yeah, and the problem was like the systems where people have to model all the knowledge, and the number of people who are able and willing to model knowledge is very low. And also it's very complex and it doesn't scale because it's too expensive. So you use it, but in different ways. So though I think that's where large language models come into play later on. And during this PhD thesis, I thought a lot about how to make it easier and accessible to build this stuff. But to continue the story, so to go not too deep in the details, you can like read the PhD thesis for free in the internet. Just Google my name and you just can download it for free. It was, as you get a feeling now, very complicated, and very less people can get a feeling for this stuff. So it's too far away from most people. So especially like 3D technologies and stuff like that, it's too complicated. So we developed the idea of the company a little bit further. So what we found in the project is basically that in early stage concept planning, most companies use PowerPoint, Excel, and Visio. So
The
you
good
have
old
cut
Excel.
tools. Yeah, Excel, yeah. So you have like cut tools, you have simulation tools, but they have two disadvantages. At one point, the license costs are too high. So even companies who develop this software don't give all the employees the software because they account themselves the software, and it's much too expensive. And so not everybody has access to it, and not everybody is able to use it. So like I see, and I talk to a lot of like system integrators, a lot of automation solution which is basically planned in PowerPoint or Visio. And that's like nice, but like, do you know what is the expensivest arrow in planning? One of the most expensivest arrow when you plan a factory or stuff like that. So automation solution.
What is the most expensive thing in
Arrow,
planning?
planning arrow in early planning.
Over or underestimating the costs or the time?
No. Some very basic. Someone forgot a pillow, so eine Säule. Someone didn't use to check it. It was not on the plan which was given by the company because they have like some building or after building. They don't have the information, and you plan like a big automation line, and then you want to build it up and there's a pillow. And like delivery time is very long, and you have to reconstruct it. So engineering is very expensive. And so you lose a lot of production time. You spend a lot of money to get the parts. And then you have to reschedule the whole thing because it's then perfectly fit in the area. So though like everyone thinks about I don't optimize this or optimize that, but like the old saying, garbage in, garbage out. The first planning steps, the errors you make in this phase, are the most expensive planning errors you can do. And they are very, very simple. So you forgot something, some infrastructure element you can't kill. So and that's I think a lot of people miss. And also what's also the problem is like for companies, like especially business development, you have to communicate with the customer. So most companies don't know exactly what they need. So most companies are expert on their products, but not expert on automation of the products. So basically,
Especially for companies that are very deep tech and that are spin-offs of university, because people are used to just being on the product versus you're, and this is a recurring topic in this podcast as well. You don't build and then go to the customer and try to sell it versus you're building very close to the customer and their problems.
Yeah.
So I'm not building something and then trying to find a problem versus I find the problem first and then I build something that is solving the problem. So this is a recurring topic, especially for deep tech founders, because they are so focused on the product, totally neglecting marketing and sales because the product is so good it will sell themselves. But please continue.
But also a good topic also in Germany, like as you said, sales and marketing. I think Germany has a lot of strengths, but sales and marketing is none of them. So like German companies, I say most companies don't have a sales. They have like eine Anfragebearbeitung, so a request working. But they don't have a sales, because if you have a sales, you go to customer, they don't know you, and then you train or you educate them that they have a problem and you can solve it. And so you can save them costs or make something better. So that's for me sales, not if someone who knows what they want and then he goes to you and then you just say, yeah, can please give me an order. So that's how most German companies work for most of the years. And I think that is also what is changing in the international competition. And also what will change also, I think, what will do humanoid robots. So I think you also like on Neura Robotics and you do a lot of like humanoid robots. And I think they will change a lot of in production. And I ask myself all the time, why people build robots who are like humans? So they are not so efficient. But like you have one big problem in automation. And the problem from my point of view is the programming. So if you have an automation project, 50% of the project is engineering costs. So it's not the hardware, it's the engineering. And like humanoid robots can replicate human behavior through AI. So you train a robot basically by showing the robot what to do. So I think this is the biggest advantage of humanoid robots. Where do you see it?
I mean, there's a big hype around humanoids, right? Especially this year. This is also a recurrent topic on this podcast. This year was really the big breakthrough. You see all the names, some you mentioned. I mean, Boston Dynamics just put Atlas to sleep to come up with a new one. We see Unitree. There's a 16K version out there that you can buy, and that has been sold out as far as I know. You have you have a few companies that are in that space, and the market seems to be very big. I speak to a lot of people that are asking themselves, does a humanoid robot really need legs? Why? Because this is not what 1X is doing, for example, with Eve. It stands on wheels and then just kind of run. Because having legs is adding up in a complexity that is not really necessary, right? You were asking where is the advantage of a humanoid? The world is built around people. So I think this is the biggest advantage. So, and the world is not built around robots, it's built around humans, right? So one of the biggest market, and this is the direction that neuro robotics is going, household, right? So getting into, because we have more elderly people and more elderly demographics all over the world, especially in industry countries, as Germany, for example, and you do need someone who is being able to serve them, to take care of them, but also in every household. We don't want to do our dishes. We don't want to vacuum our floors. We don't want to clean our windows. So the world is built around us humans. So having someone who is being able to do these kind of things, most likely, not necessarily, but most likely will have a look like us, right? Even though there are other existing robots that are doing a pretty good job already, and they don't look like a human. Hello Robot is one of those examples that is available already, that you can buy, you can purchase, and that is being able to do some certain stuff. But I'm giving back to you.
Yeah, and I think that's a very interesting topic, what you said. Okay, you have robots and they are more and more capable. So you see one innovation after another. And then you have one big problem, the change. So people don't like change, and most people are very slow in changing. And that's where the two worlds collide. So you have technology which is increasingly faster and faster and faster evolving. And you have people who can't get up with this change process.
Yeah, true.
And that's the problem. How to make this change process faster, because the change will happen anyway. And you lose currently a lot of people. So we are both from the technical field. So we know a lot of technical people. But if you go like on the city to any people who are not in this field, they don't understand what will happen. Any though. So I think there is a huge collide, and that's where we come with Robotop into the game. So what we do basically is, like in German is a saying, a picture is saying more than 1,000 words. So I can tell you something, but if I show you or let you do something, you more easily understand. And sometimes hardware is very expensive to scale.
Yeah.
Or for like big companies who have like big machines for trade shows, it's very expensive to buy big booth and put them on a trade show. Or if you have like complex processes of analytics process or a specific manufacturing process and you want to show your customer, it's very expensive to show them the real. But there is a virtual world. So if you have like digital twins or digital replicates of the stuff, you can use them at a trade show and let people walk through. So interact, show them on virtual reality glasses, on an iPad. You can project them like with augmented reality in the real surrounding, and people can walk around and see, oh, this is this size. Oh, I thought it was bigger, it was smaller. And what you can do, and what I would do if I were at Robotics, is you can scale the idea of a humanoid robot. So like you can put it on like every trade show and show people, but the hardware has some price. But if you have like a digital 3D model of the robots doing specific tasks, then you can like host the 3D model with an animation on a website, and then someone can scan it with his smartphone and project the robot in his living room. And then he sees like a robot doing a specific task, like a household task, cleaning up a bed, or some specific task the system is supposed to do. And then, seeing is believing, he gets an understanding how the robot will do the tasks. And
so
that's,
this is the way you would do sales.
I would more like prepare the sales for the masses. So it's all about how to change or give the change process a go for as less money as you can. So you have like platforms as LinkedIn, TikTok, and Co. And if you do it right, as you also know, you can reach a huge audience. And this is, I think, when you do it right, the cheapest way to reach a huge audience. And if you have like a 3D animation, so it's like basically a 3D model or 3D cinema with some specific movements. And then you can provide like a QR code, and someone is scanning this QR code. And then he can like watch it on his computer or just in a web browser, like a 3D animation. But he can also project it with a tablet or a smartphone in his living room. So like, I don't know if you know also IKEA, you can go on the website and then you can put like every furniture in your living room. And basically you can also integrate 3D animations, and this 3D animation then gives a better understanding how the robot or the solution can serve you.
It sounds like a good idea, but there's a few flaws. I at least not maybe not necessarily flaws, but there are a few ideas I have or questions I have. So when a mobile phone is something that you can afford, even though they are very expensive, right? So if you're buying a phone, it's still affordable, or some people do it in paying it in monthly payments, right? But humanoids are not in a scale, even though a few days ago Elon Musk said again, the price range of a humanoid needs to be between 10 and 20K, right? So but 10 and 20K is still, I'm not necessarily say this is affordable, but for the majority of people, it's not, right? So when you start with a technical product that is very expensive, your end user will most likely never be B2C. It will always be B2B because you need volume to be able to buy it and to make it worthwhile. So the ROI needs to be there. So if I have a humanoid that will cost 20K or 10K, so the majority of customers will be enterprises, corporates. So restaurant chains or hospital chains or government. And maybe it comes equipped with a kitchen, which costs 20 or 30K, right? So with end users like you and me here in my flat, having a humanoid for 20K, I do need to make a very decent amount of money to be able to spend 20K on. I mean, it is definitely over the time it will be less expensive than someone who will helping on a regular basis in my household. But so there's a reason why I'm saying sales in this kind of scenario makes sense. So if I have a customer who is in charge for a hospital chain and they do need desperately someone who's taking care of the people, bringing the people around, bringing the food around, bringing the people from A to B, and then showing them, because you're absolutely right. This is the reason why, especially in Germany, we do so many POCs in the industry, because every single customer thinks his production line and his product is very, very special. And I do need to see your product on my application in my environment because I don't believe you, right? So I do think the solution has its meaning, but maybe not necessarily now at the moment for humanoids. But who are your customers? What are the use cases where your company comes into place?
So just a short case, I want to go a little bit back to humanoids and then we can go into the other topic. So I think there are 2 points I think I would see differently. At first hand, change takes time. So there are like studies on like I think what was it, propaganda, and it's very interesting because if you see a movie often enough, then you think at some point this is the case. You change your thinking, but at some point you forget where you get the information from. So there's very interesting things. That means if someone sees a robot often enough doing something, at some point he thinks it is possible. So what you like have to have that people get in the faster change process is that a lot of people have to see humanoid robots. So currently it's too expensive. Not everybody sees a humanoid robot. But what you can do is if you provide an augmented reality model, so depending on how good you prepare the animation and stuff like that, you're between like 2,000 and I think 50,000, depending on the quality and stuff like that. You do it once, and then you can provide it via web link. And then people can start to create like TikTok videos and stuff like that, or just look it on their smartphone. Teacher can just use it in lecturing to show it people. So it's a very, very affordable way to scale that knowledge in parallel to different other activities. Because at the end, even the guys who are in B2B, they have children. They also on social platforms. And at the end, seeing is believing. So I think it's more a way to combine it. So to make information and seeing the robot work as accessible as possible. So I think you don't start the change process if everyone had it, because then it's not necessary. You start it now because it's very cheap and scalable. And then you add it up to other use cases. And also to bridge the cases who are our customers. So basically, if you look at the current market, you have like in engineering like the Begriff durchgehendes Engineering, so through-going engineering. And the idea is that you start and then you use the information during the engineering process and develop the ideas into more detail. The problem is what we have currently, you have marketing and they sit in their bubble. You have sales and they sit in their bubble. And you have engineering and they sit in their bubble. And sells the stuff engineering is doing. And marketing is the stuff people want. So to some point, you cause a lot of problems because salespeople just like to sell, but it's not the best solution for the customer. Then engineering have to build it no matter what because it's sold. And marketing is just promoting stuff, but it's not basically all the time the best stuff which would be the biggest advantage for the customer. And you have also different technology. So marketing has its technology and engineering had their technology and sales have their technology. So basically you do in a company 3 times the effort because like marketing is using design tools and they build like videos and animation and stuff like that they put online and like build one-way trade show demonstrators. And then you have engineering, they build the stuff, but basically most of the engineering solutions are not used for marketing or sales. And sales is just putting together their PowerPoint slides with videos they take from customers and stuff like that. So you have like this 3 separated branches, all
But this is a
working
very
with their
bad
own
company you're
tools.
talking about, right? So, I mean,
Oh,
you're right. A lot of companies are working this way, but this is kind of the prototype of not how to do it. So I think there's a lot of effort going on in not having 3 separate units that are don't talking to each other, and one hand doesn't know what the other one. I mean, you're right. A lot of companies,
I
doesn't
think
matter what size,
80% of
working this way. Yeah.
80% are working. I also know companies which do it the other way, but they are the elite companies. So there are some companies like who have a good boss and they have a system in doing that this way. But what we see the default case is just separate branches. And what we basically do, and that's a little bit the problem for most customers to understand, and that's the reason currently we sell 2 solutions. At the one hand side, we have a very usable 3D planning software. So with our 3D planning software, I can train people who are able to use PowerPoint in 1 to 2 hours to do 3D planning. So if you want to, we can do the experiment also with you. So with everybody, we are able to train the people very fast. So if you are at the customer side, and that's the current problem in sales, so sales is at the customer side. Then he talks to the customer, say, oh, you have this and I have that, and then say, okay, we can do this or we can do that. So you have at some point consulting to the customer, what's the best way, and most customers who didn't automate anything, they think specific tasks are easy to automate. They are mostly very hard to automate, and they think some tasks are very hard to automate, and they're mostly very easy to automate. So you have to train the customer to say, please start with this task because it's so easy and it gives you a so good return on investment, and don't start with this one. But therefore, the sales has to do a little bit education of the customer.
Yes.
And then he goes with a pen and paper, writes down all the steps, makes a drawing, and it's not scaled. Then he maybe writes like 10 meters, 5 meters, and he does something, but then he gives it to the engineering. Then the engineering in the back office is like doing, if they do it, a 3D concept. It takes 2-3 weeks, and then he goes back to the customer, and then the customer says, oh, I don't like this. And then he goes back to the engineering, and it's a very long process, and it costs
obviously.
Costs a lot of money. And if the if the sales guy just could use old examples of projects, so best practices, and give it to the customer and say, okay, this is a good use case, this is a good use case, and I can show it you because I can put it in augmented reality in a tablet in your hall and I show you how it works. Or this is a good use case. And then he can make like a first concept drawing, like putting a machine, putting safety equipment, putting stuff together, and has a first 3D concept. And then he takes his smartphone and then he can just make with his iPhone a 3D scan of the environment and has some specific information, like which is very important because for the logistic process or for connection to other machines or stuff like that. Then he can create very fast a 3D concept, show it to the customer, and later use it for engineering. And then engineering can build on top of this the concept. And as you said, sometimes then if the customer orders, maybe you have to go in a very deep level simulation or a very, very deep level construction process. But then the customer already paid for the project and then you get paid for the stuff. But otherwise, you don't get paid. And then if engineering creates a use case which is very attractive, then you can give it to marketing. Marketing is enhancing it a little bit and creates out of this videos and images, like for reference stories on LinkedIn, or put it on a computer. You can get a Xbox controller and then you can go on a trade show and walk through it and have a 3D experience how a solution is looking. And then you have a circle. It's very less effort, but that's currently the reason people don't think like that. We sell planning or marketing because it's very hard to find the company, because we talk to a lot of companies and some companies are buying our planning solution and some companies are buying our marketing solution. But the technical or the more technical companies like the planning stuff, and the more marketing and sales oriented companies like the marketing and sales stuff. But I rarely found companies who like both. And
But you're selling both.
Yeah, it's one solution, it's one software, but I have to split it in different packages. Otherwise, people don't understand. Because as you say,
But then again, that means actually, because it's your solution, right? So you know your solution best.
Yeah.
But we were talking about change management and educating customers, right? So maybe this is a bit too harsh here, but maybe you need to do a better job in educating and elaborating on the tool and selling the benefits of the tool. Because when the customer is unable to see the benefit of it, then the benefit is not clear enough. But this only to some certain extent, because we both know some customers are just unable to understand or unwilling to understand. So I can understand that from a business perspective, you do need to do what you need to do, because even though it does not make sense, you do need to deal with it. So yeah.
But they're saying from YouTube, so a little bit new stuff creates curiosity.
Yeah.
Too much new stuff makes people just I don't understand. And that's the I think a little bit the challenge we're currently working in, and I think we will face it with a lot of storytelling stuff. But and also with like that's also, so I also tell a lot of the stories with Lego, because if I tell, okay, when a 12-year-old child can build a robot in Lego, it's technically possible. So we just have to do it. And so what we basically do is like we create the engineering tool like Lego. It's so easy. A 12-year-old could plan and configure it and do the stuff. But currently, we just work with early adopters and innovators due to that reason. So we have a lot of like early adopters and innovators. And with them, we have very successful projects. And the other guys, I just say they will follow on, because as that's also, I told the story with the education system, we have no 3D technology. So a lot of understanding is missing. And so for most people, the gap is too high. So that's the reason we focus on like the early adopters and the innovators. Like if you know this early adopter innovator cycle, so we basically work with early adopters and innovators. So basically just that's also I was last week at Yasha Roman's conference. So I met there a lot of people who were very, very interested in the stuff we are doing. because there was a high density of highly innovative people. And so we just have to select currently who we're talking to, and to make it more easy, we just sell one part of the solution because it's easier digestible. And later on, we will upgrade the people to the other stuff. But
Makes sense.
yeah, it's as you say, it's a little bit complicated to make it easier. And as you know, like with other stuff, it's the interesting and also the challenging part in business development. But yeah, it's a great fun. And basically, I say we want to make it accessible as Lego and as easy to use. And with our like early adopters and innovators, we train them. So we added like to our software solution a lot of like consulting and training for our customers. And they're really happy to use it. So we just thought, okay, we just sell software and they do the rest. But currently we added a lot of consulting and a lot of training, and then everyone is very happy.
I mean, it's funny because it seems like this is a very cliche, and this is very, very much what happens, right? That even though the technology is very good, it's still too complex. And you say everyone can do it, and it's easy to do it, but the reality is very often not everyone can do it, and it's not easy to do it. So you do need to sell a lot of extra service, education, onboarding, doing the first steps and the first wins with the customer. So I've experienced this just before I joined Nora with my former company, because this is the wish, this is the end vision where you would like to go, but we are not there yet, right? So the gap is too big. So you need to help and bridge that gap, right? I do think that I would like to see it in reality. So let's definitely catch up in real life, not only via this podcast.
Yeah. So it's as you said, I think it's a change process, and you have like two ways of change process. The one is like what's very easy. What we can do is to train people to use the software. That's the easy part. The much more harder part is to train people to think in a 3D world, because currently most people are used 2D software, though they think mostly 2D. But that's what people don't understand. So we had like one customer who said, okay, I want to have something on my homepage, and say, can you integrate it? And say, yeah, I can create a video out of a 3D scene, no problem. It's very easy. It's just a 2D representation of a 3D world. and most companies just buy videos, and these videos you can't adjust, but with a 3D world you can do it. And so you have to train people to think more like 3D and extended reality. But when they understand it and start to think like that, they understand, okay, so much stuff is getting easier. It's like, I don't know, did you learn programming? I think the example, like, because we have a lot of people like from programming community, though, like object-oriented programming. Does it say something to you?
Oh yeah, but I have no experience in that. So I know some programming, but basically.
Okay, so for people who are familiar with object-oriented programming, if you start with object-oriented programming, and that was the hard part for me when I just first programmed, it was you have to change the way you think. It's like if you start the first programming, you have to think like in a different way, and then you can do much more. And with object-oriented programming, you have to learn, okay, when I make modules and methods and stuff like that and variables, then I can do, much more stuff and in more efficient way, but it's not the way I was used to think. And
okay, got it.
And it's like with 3D, you have to learn a different way of thinking, which is not possible in a linear 2D software. And that's the funny part, but also the hard part. And but the goal is to make it easier to Lego.
I think we are a little bit, no, we are still far away from where we would like to be, and I think we are far away from from this accessibility and the usability. But yeah, this is a starting point, and I think once you experience this augmented reality or the different words or different version that exists around this topic, I think everyone will very easily experience and see the benefits that you have, right? As you said,
Yeah.
I mean, why are houses, when you sell them, are staged? Because people have no imagination. Where should I put the couch? Where should I put, right? So, and this is
Yeah.
the reason why real estate people stage houses, because people have, it's very hard to imagine, right?
Yes.
I do think that I would like to see this in real life. So I'm
Yes.
very happy to continue a conversation afterwards. I do
Yes.
think that this is one of the longest episodes we had so far. So it seems like there's a lot of things to discuss about this topic. It shows that there's so much potential in it as well, right? Especially in the
Yes.
sales process is just one part, but
Yeah.
planning and yeah, these kind of use cases that are mainly your business are definitely there. So I think not only from a private perspective, but maybe on a business perspective, we need to have a talk afterwards.
Yes.
I'm very happy
Yes.
that you took the time. I hope that you yeah, that you had fun as well. I do
Yeah.
know this is a different environment here, and maybe not the way I used to do the podcast, but yeah.
Yeah, but maybe next time. And I think why this is also very fast evolving is Apple and Nvidia is pushing this stuff. And that's what a lot of people have to think about. And so I think if you have a company like Apple and Nvidia is doing it, and then you know the momentum is starting. So
The hype is
thank
big. The
you.
hype is big. I think there's no question about this, right? But you are in the business, so you know this even better than I do. There's the hype, and then there's the reality, and we do need to close that gap, right? Because what this hype does is people or customers coming into a situation where they think this will solve all my problems. This will be very easy. I can do it everywhere, but no, the reality is a little bit different. So,
But to end it, yes, we will solve it, the problems of Robotop. So let's discuss it afterwards. And
I
was a
will.
great fun to talk with you. Thank you for your time. And yeah, enjoyed it really.
Let's have a talk in the near future. Thank you for your time, and talk to you soon. Bye
See
bye.
you. Bye.